Hello, and welcome to the Six Figure Developer Podcast, a podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
With us today is Maxim Fateev. Maxim has worked at companies such as Microsoft, Google, and Amazon, and now works as a staff software engineer at Uber. Welcome, Maxim.
Thank you.
So, Maxim, before we kind of get into the meat of what we want to talk about today, would you give us just a little bit of how you got started in the industry? You were kind of talking to us a little bit about this before we started recording.
So, in the industry, I started at Brazil because I was studying at the university, doing my master's degree, and they had this nice program that university practically was participating in industry projects. And I was working part-time in the telecom, Embratel, which was kind of big AT&T of Brazil back then, and we were creating this 1 million lines, huge C++ system. So that was probably the biggest kind of industry involvement back then. Also participated in the project in medical insurance industry. That was kind of the biggest industry. And then I moved to US and actually worked for big AT&T. My first project was a contractor for big AT&T in New Jersey. That AT&T, and we were doing the IVR applications, interactive voice response application, those 800 numbers, and it was like 20 years ago. It was actually pretty exciting back then. It was a very big platform. And then I moved to Seattle area and stayed here since for a long time, working for.
Now, your accent doesn't sound Brazilian.
I'm Russian, yes. I was born in Russia, in actually middle Siberia, when it was like 45 degrees Celsius below zero. And,
wow.
I still cannot go to the sun without getting burned in 10 minutes. But yeah, I have a degree, actually, a physics degree from Moscow State University before I moved to Brazil and have my computer science degree there.
Awesome. Okay, and you were telling us earlier that you you've worked for Microsoft and Google and Amazon. Now you're at Uber. How can you? What can you tell us about what you've done for those companies?
So I think I cannot consider myself still Amazonian. I think most of the interesting contributions I've ever done were at Amazon and now at Uber. So I kind of Amazon Uber. And I had the stints to, like, I worked for Microsoft and Google, but I wouldn't say I have something I could be proud of after I worked there, which I could show publicly. But at Amazon, I built quite a few solutions. I think the most interesting ones are messaging system, and I think at least design of that system still powers a simple queue service at the back end, and a simple workflow service, which is still a public AWS service doing these orchestration things. And practically the product which I work on right now at Uber is actually Cadence, which is a continuation of the ideas of the simple workflow.
Awesome. So what is Cadence? Would you explain that to us?
It's actually hard to explain. We call it a workflow system, but the problem is that we hate the name workflow in it. Because every time we say workflow, people start thinking about existing technologies, which are more like about sequencing steps in certain order and synchronously, and we are much more than that. We are probably the closer to, from the existing system to the ACA, like actor frameworks, or Microsoft Orleans, which is kind of similar. But practically, this is a system to create virtual objects which don't die and can live in the cloud and in this farm of machines, and they allow you to write your business logic directly without thinking about complexity of the distributed system. It greatly simplifies your development, but it's certainly a new way to do software, which requires some learning curve and understanding what we are doing.
So what types of things are companies using Cadence for?
It's practically, it's interesting. You can use it almost everything which is beyond just simple request reply. We have people just using for distributed cron jobs. This is probably the most simple use case. But you can do it, for example, deployment workflows use it to deploy services inside of Uber. Then you can do business level workflows. For example, when we've just recently acquired Jump, Uber owns Jump bikes. And they are rewriting the internal systems to actually, when you press a button, it actually starts a workflow. And then everything which happens after that can be modeled as practically a bunch of these virtual objects inside of Cadence. And we have all sorts of scenarios, practically all over the place, from business level workflows down to infrastructure level workflows, deployments, monitoring, and so on. It's almost everything. Practically every time you start about thinking about database, this databases in queues, or cron jobs, or timers, or moving files around, or big data, Cadence is very applicable. Other thing which is actually, you can practically take any existing workflow system and make it run on top of Cadence. So practically without modifying your workflows. So if you have BPMN engine, you can toss it out and write for the BPMN, run with BPMN workflows on top of Cadence. We have internal workflow engines, and we switched quite a few of them to Cadence. So you can maintain your workflow definition, and Cadence is so generic, which allows you to practically have just one engine for all of them.
All right. You mentioned cron, which for anybody not familiar is basically the just the timing and scheduling system for a Linux machine. But is timing the only way to start a Cadence workflow, or what other options are there for initializing a workflow?
So to initialize a workflow, the most common one is actually just calling start workflow execution API. Also, another one is signal workflow, which is practically external event. So from the business point of view, for example, you can listen on Kafka stream or whatever messaging queue stream and just start workflows when you receive events. Or if there is an event which is related to that particular workflow, and workflow has ID, which is a business level ID. For example, inside of Uber, if you're processing trips, you can use trip ID as ID for the workflow or customer ID. And then you just apply those events to that workflow instance as they come. And they can be, practically, you can create these workflow instances lazily if necessary. That is kind of the main ones to create. And then even if you create cron job, you still would start that cron job passing the schedule to it. And but when you say cron, it's more like distributed cron. It's not for a single machine. It's in a cluster.
Yeah. So you've likened it to Orleans and Akka, and you said those are actor-based systems. So is each actor kicked off by some system event, and then it runs through, and then it can trigger a number of other system events that might start other actors in the system, or does Cadence not exactly use actors that way?
So you could do that as well. Absolutely. The biggest difference, we don't call it actor system, mostly because actors are usually about threading model. Practically, they say actor is an object which has single thread of control and doesn't block that thread, and so on and so on. And we don't actually, you can write applications this way, but it's not required. For example, when you write code using our Java SDK, you actually get blocking calls, and you can have multiple threads. So this object can have multiple threads, as many as necessary. It can do parallel tasks. It can have its own futures, promises inside. And the threading model is actually much more flexible than normal actors. When I say actor, I more like mean that object which has its own state, and we preserve that state, including actually state of the stack traces. So, for example, if you call sleep, and sleep is for 10 days, from your code point of view, just sleep 10 days on that line. And the 10 days later, it just unblocks. But conceptually, it's not linked to any specific process. So you can do practically, this process can die as many times as necessary. And it's not even consumed memory in your process because it's just will be passivated at the side of Cadence server. And then 10 days later, this timer fires. We will reconstruct your state up, down to this stack trace, practically all local variables and everything. And then it will just continue.
Okay.
And then starting the, sorry, I kind of sidetracked a little bit, but you obviously can start, workflows can start other workflows. For example, you can do child workflows, or you can send notifications to them. So your application is usually not a single workflow, it's actually set, that's why I call actors, because it's usually a set of those objects communicating to each other. For example, inside of Uber, you would have trip object, like rider object, driver object, and they would communicate to each other asynchronously to achieve some common goal.
Okay.
What are the technologies involved in Cassandra? In Cadence?
Actually, Cassandra is involved right now because we use it as a backend store, but we can swap stores. So right now we are finishing up the SQL implementation. So you would be able to use SQL as a backend, but that is the only like hardcore core dependency of our services persistence. The rest is written by us, and right now the server is written in Go. And we have 2 clients right now in production, which is Go client and Java client. But as we are using Thrift APIs in the future, we are planning to switch to gRPC clients in other languages, absolutely possible.
Why the decision to go with Go? Is there any benefits to that, or is that just what the team is comfortable with?
Both. We already wrote one product, Share Me in Go, and Go is de facto standard at Uber. Not de facto, it's actually standard at Uber for its backend services. And we practically standardize on Java and Go right now. And the other thing, we had good experience with it. I like Go about mostly not for its feature set, which is pretty limited, but mostly for its simplicity. You can get a developer, which is new developer to a team, which never write a line of Go code and start producing practically production quality code in a few weeks, learning the language. Other thing is coroutines, like Go routines. In Java, every time you have a large number of parallel things, you need to go async. And async Java is ugly. I know that we have all these new features and lambdas, it's still ugly. In Go, you can just spawn as many Go routines as you want. You can have 100K of them parallel, and it still doesn't kill your processes and it scales.
And it looks like it's, is it 100% completely open source at this point?
It is 100%. The only internal things we have are bindings to internal system. For example, we have interface for a monitoring system for login, and we just introduce internal bindings to them. But the whole thing is absolutely open source. We actually do all our developers in open source. You go GitHub, you see all issues, all commits, everything is there. So because our previous project, we converted to open source, it was pretty painful process. When we started Cadence, we just started developing on GitHub right away.
Do you have a lot of outside contributors, or are they all internal at this point?
So we do have some, but it's pretty small right now. We wouldn't say we have large external adoption yet. We are talking for quite a few kind of big name companies, but I wouldn't say that we are highly adopted yet. But I think one thing which kind of slows us down a little bit is Cassandra, because not many companies have managed Cassandra as we do have internally. So I think after we switch to SQL, at least provide SQL bindings, it would pick up a little bit. That is kind of one thing. Also, Java client is relatively new. Initially, we only had Go client. So I spent probably most of the last year actually personally writing most of the Java client, because which was actually ported from simple. It was started as simple workflow client, which I wrote for AWS, and then I kind of just rewrote it mostly to run as Cadence client. So right now, if you're a Java developer, you certainly can use this, and you will benefit a lot from that.
Yeah,
but
it looks
yes,
like
we plan to get a lot of external customers eventually. But again, that's why we're talking to you, because we need to explain to them what value we provide first.
Yeah, and it looks like in the GitHub repos, you've got a couple of sample projects, little tutorials, and of course the obligatory Hello World example. Are there other places or other resources out there that we should be looking at when looking into Cadence?
So practically right now, you start from our GitHub repos. We have documentation there. We have right now the site.
It's cadenceworkflow.io.
Yeah, cadenceworkflow.io. But if you just Google Cadence space Uber, and you will always find it. And then you start from samples, and we just file issue on our GitHub if you have issues. We also have Slack channel, which people can ask random questions there.
So is you said that there's only 2 SDKs right now, but you're planning to have more later. If someone wanted to look at Cadence, is it currently production ready, or is it still so kind of in development, alpha, beta, or something like that?
So it's been in production at Uber for over a year, and it's already used by dozens of very important use cases. So we are absolutely production worthy. And actually, this team is not the first large-scale production service built by this team. So it is absolutely production worthy. And we also launched recently, not recently, half a year ago, the cross-Datacenter replication, which is a very important feature inside of Uber. So practically, if you use AWS technology, terminology, sorry. You can have one cluster in one region, another cluster in another region, and you set up asynchronous replication between them, and means that workflows will continue executing in another region if failover happens. And you can fail over individual domains, which are more like namespaces. So you can application practice say run in this region, but if something goes wrong with my service, failover. And that was a requirement to use with most tier 0 services at Uber, because without a full data center outage support, they wouldn't use us.
Okay. Is Cadence is there a software as a service offering for it, or is it something that a company would have to set up in Amazon themselves and then run it on their own E3 or AWS or whatever?
So right now they have to run it. We don't provide it because we are not like a cloud provider at this point, at least Uber. So you have to run it. But setting it up is relatively straightforward. Right now with Docker, all this configuration became much simpler. For example, for development, all our developers at Uber and outside, they just use Docker container. They just download the Docker Compose file, do Docker Compose up, and you get full-blown instance of Cadence server with Cassandra and even with UI, web UI running on your laptop. And you can practically do end-to-end development of your workflow fully on your laptop. And then for deployment, you will need to, especially when we switch to SQL, you can use probably RDS or Aurora, whatever SQL offering you use. And then you will need to a few Docker images running somewhere as a service. And then you will need to have your workers, which are more like application level processes. But the single service is multi-tenant. It can be shared by multiple applications.
Okay, that's awesome. Is it just Cadence on Docker Hub? Like is that the name of the image?
So I'm not sure about that exactly, because also the image we give you for development, we have instructions linked from our GitHub page, how to set it up. Mostly you need to know which Cadence Docker Compose file to download. But the actual service, I'm not sure if you can use that one or you need another one. But if you're planning to do production deployment, talk to us first. We certainly will help you to set it up correctly.
Okay, yeah, I found the Docker file on the Cadence GitHub. Looks like it's built up there. I'd have to go look on Docker Hub to see if I could find it, but it is available on the GitHub, so that's nice. So probably the majority of our listeners are .NET developers, and C#'s not one of the supported languages yet, right?
Not yet. Actually, for .NET developers, if they want, they probably know about Arlene's project, and also they might maybe heard about Azure durable functions, I think, or durable task.
Yeah.
And this is actually it's actually interesting. Another top developer of my team, Samar, he worked for Microsoft, and he was actually the guy who conceived the durable task. And the reason he did that because he worked for a simple workflow service with me at Amazon. So we kind of go these circles. And Cadence is probably like, let's say, much more scalable, robust, and feature-rich version of durable tasks. So we absolutely would love to have binding to C# and have all these features available for C# developers.
If someone feels like they have the power to help out with that, who would they contact? Could they contact you or?
Just contact us, yeah. Should issue on GitHub, we will help you. Obviously, it's not a simple project, especially if you want to do workflow implementations itself. It certainly will take a few months of somebody's time, but I can, as I wrote a couple of them already, I certainly can give very detailed instructions how it should be achieved.
Okay, excellent. Thank you.
So one of the things that you talked about that these are very durable. Could you talk a little bit about what kind of configuration options you have there and what kind of features are around the durability?
So we don't give you much configuration options around durability because our durability is kind of 100% by definition. But the only kind of configuration options are more about retention period after workflow is closed. So we don't have any limits on duration. So at least in the software, so if your workflow should exist for a year or two, we allow that. Any activity execution can take as long as necessary. this is the biggest difference. For example, if you are used to do workflows using, for example, queues, SQS or Kafka or whatever, they are not good when you have long-running tasks.
Mm-hmm.
For example, if you have tasks which runs tens of minutes or even hours or days, they're just not good for that. In Cadence, you can have practically unlimited activity execution time. And obviously, we support heart beating, and you can have long-running tasks which heartbeats as long as necessary. And this is kind of poor man leader election. Actually, a lot of scenarios people use us as just kind of like leader election. They just start activity and it heartbeats. Heartbeat stops, the activity is automatically executed on a different host. That is kind of one of the basic scenarios of using us as well. About other things, yeah, so that is kind of about durability. Other thing which we are finishing implementation right now is archival. So in the future, even if workflow is closed, we will just push its kind of state to the S3. And then it means that you would be able to query its state or do troubleshooting later anytime, as long as necessary, as you want to keep it in S3 always.
Cool.
All right. And excuse me. At the risk of going too deep into the technology, were there any challenges in development of Cadence that you got to a point where you had to solve a particular problem, or you had to work around a particular scenario? Is there any thing that kind of sticks out in your mind of we had to solve this particular problem, or anything to that effect?
Oh yeah, we had a lot of problems to solve. It's actually almost every component of Cadence is certainly very non-trivial. From technology point of view, one is we had to work around a lot of issues with Cassandra, mostly because Cassandra is not wasn't built to do transactional updates. So they support lightweight transactions, but they impose a huge performance penalty and also have a lot of limitations around concurrency. So we took a long time to make sure that our system works with Cassandra in a way that it doesn't break it and is very reliable. Other thing which we had to build is practically is we internally have a lot of queuing support. So practically every time you execute activity, we actually queue the activity task inside of our system in a special queue, and then workers pick it up. So we kind of support this queuing semantic. But Cassandra, if you, for example, run a Google query, say queue and Cassandra, first hit will be queuing in Cassandra is anti-pattern. Don't do queues in Cassandra. So we had to kind of design our own queuing mechanism on top of Cassandra in a way that it actually doesn't break it and it's kind of fits their model. So it was hard. And from the conceptual point of view, I think cross-Datacenter replication was most non-trivial task because we are fully consistent service which uses asynchronous replication, but needs to deal with, for example, situations when by mistake or for whatever reason, both clusters are active. So we need to be able to resolve conflicts and without losing single message, single external event. And that was actually, I can tell you, it's an amazing piece of work our engineers did to make sure that not only design that, but actually get to the point when it's actually production worthy. And it's a really non-trivial system because we're actually doing all replication on the application stack.
Would you say it's feature complete at this point, or are there additional items that you want to plug in to Cadence, or is it just working on additional SDKs at this point?
No, we have a lot of plans. It's we certainly absolutely not feature complete. We have a lot of ideas how to move it forward. And obviously there is extensive put of like things like, for example, we can add new languages to the like mix, but then we have a lot of ideas how to. So one thing which is right now mostly at Uber, people use it to implement internals of their services. So practically they use it as a technology to implement. For example, if you every time we have this internal process of when people create new design, they publish to a special internal site, and there is kind of a review process. So I monitor that list of those documents which are coming up every day, dozens of them. And if I see somebody saying, okay, we are going to use Kafka database and something to implement some asynchronous flow, 99% of cases, them switching to Cadence is beneficial. Practically, because as soon as you implement in workflow, technically, as a background process, Cadence gives you a lot of benefit. And but one thing which we are not doing yet is cross-group communication, cross-service. Because workflow can be seen as a service which supports long-running tasks. Because right now, if you say service and architecture, you always think request reply. Or maybe you have services released on queues. But this is it, right? But if you say, okay, I call some service and operation, takes 5 days and replies me back using the say, for example, free proto definition, it doesn't exist. And on top of Cadence, you absolutely could build that. You could build system which say, this is my service, this is my SLA, this can take 5 days. Please call me. And then you can just use Cadence Practice as a service bus to actually do cross-team communication. We are not there yet. We are planning to add all this support. Then we want to add metadata services, practically to be able to register your jobs through UI and being able to invoke them using these nice forms and everything, managing your cron jobs and so on. That is kind of another area of research. Then what else? Cross data center, right now we are kind of passive active in the sense that every domain is active in one data center. Maybe we will be able to kind of make this highly transparent and then it just runs everywhere. You don't really know where it's active. There is kind of other area of investment. What else? Yeah, we actually, at some point when we just built it, I thought, oh yeah, it's kind of there. But now I see that we have, other thing we are just considering is adding transactions. For example, transactions across multiple workflows. Right, you want to update 2 workflows transactionally, kind of do 2-phase commit, or if you use, for example, Google Spanner, we just use them natively. And then you can update, for example, if you have trip and like trip and rider and driver, you want to atomically update them instead of doing async communications right now. So that adding those type of features. Then we can do shared data structures, for example, like counters and like you know this like log-free data structures like distributed ones. What's the acronym? I don't remember. But we can do also other thing. We don't support one-to-many. Right now, you need to send event directly to a workflow. There is no way to say, okay, all workflows which have this tag receive this event. That is another. We also adding the better support for querying multiple workflows by tags. Right now, we have limited. You can list workflows like, okay, which ones failed in this period of time, which are open. Give me all workflows by that type, but you cannot do user-level queries, for example. Give me all workflows which are in this particular state. And pretty soon we will be able to answer those queries as well.
It's really cool. Well, do you have, excuse me. Do you have some words of wisdom that you might be able to sort of speak to people who are just getting started, and maybe Cadence is not the place that they would start, but just kind of thinking back to sort of where you begin in, you certainly talked about Go being a language that you found developers who don't have a whole lot of experience be something they can pick up. What might you kind of recommend someone? This is kind of not in the same line, but what would you recommend to someone who's just getting started in the industry?
I think be curious, okay, and try to understand how things work. I think the problem is that sometimes you see developers which can understand commands and they understand how things work from outside. But if you start asking questions about, okay, do you understand what actually happens after you press this button? And a lot of people just are not interested in understanding how things work. That's why, for example, like teaching people things like C and it's beneficial because it forces them to kind of go into a little bit deeper into the stack. And the best developers I've seen, they are people who actually spend time trying. It doesn't mean they need to understand everything, but at least they have idea what happens when they actually make certain command or Go does something and so on. You want to go a little bit deeper. And curious people who teach themselves all the time. They should focus on like learning things. And if you get stuck, also I've seen people stay in the same company for 10, 15 years and not learning much. Sure. Like I think I had one example is that interviewing a very smart guy from Microsoft, and it was awesome. He passed the interview, but then you ask him, what did you actually do? And he said, oh, I last like 3 or 4 years, I maintained a single function. It was a very important function instead of kernel. But all he knew was that function. Like, every question around, like outside of that function, he didn't know. He said, no, I don't know. And wow. I think you don't want to be that guy.
All right. Thank you. Yeah, that's awesome.
And do you have any upcoming speaking engagements or any other items that you might want to just share before we start wrapping up?
So I go to conference all the time. So if anyone who wants to invite me to talk, especially if it's Go conference, backend conference, any like services oriented, like I certainly would love to come and talk about Cadence. I don't think I have specific dates right now set. And in general, I think just when you start building your system and you have backend of your system, which is beyond request reply, and you think about queues, databases, and polling and cron jobs, at least consider Cadence and talk to us if you have questions. We are very open to give you design consultation, explain what you would get from that.
Okay.
All right, Maxim. Thanks so much.
Thank you.
That was Maxim Fateev. Maxim has worked at companies such as Microsoft, Google, and Amazon, and now works as a staff software engineer at Uber.
If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I'm John Ash.